What tools are available to anticipate how a building will operate and which combination of design features and systems is the best to meet the client's needs? Building energy modeling is a powerful tool for optimizing designs, especially where there are many conflicting strategies. For instance, to size windows to guarantee the best balance between providing daylight, minimizing solar gain, and cost-effectiveness in the selection of glass specifications. Modeling can be used at the early design stage to determine the overall environmental strategy of the building, as well as during the detailed design stage, for example, to determine the best arrangement of solar shading devices. Modeling is also becoming increasingly common as a requirement to pass building codes, demonstrating the overall energy performance of the building design. At the early stage of the building design, it is possible to rely on simplified models, such as eQuest. Here are a few examples of the types of analyses and visual representations that modeling can provide, as well as types of frequently used softwares such as Energy Plus, Integrated Environmental Solutions, IES, OpenStudio, and Design Builder. Let's take a look at a real-life example of a high-rise office building for the French Ministry of Ecology. This example will provide an understanding of how energy modeling can shed light on the effect of different designs on energy use or internal conditions and inform cost-benefit analysis of the different options. Option 1 has no particular energy efficiency component and is the reference case. The total annual energy consumption is modeled at approximately 150 kilowatt-hours per meter squared. Option 2 has incorporated a better envelope, dynamic solar shading, some natural ventilation, and mechanical ventilation with heat recovery. The shape of the building has also been changed to reduce the depth of the floor plate. These changes have significantly reduced the heating energy compared to option 1, as well as the energy needed for mechanical ventilation. Option 3 has a shallow floor plate and has designed a longer building. It has incorporated the same energy-efficient technologies and ventilation as option 2. This option has significantly reduced the cooling energy demand. Note that the energy required for heating has increased, although the overall annual energy use is still lower. Option 4 has increased the natural ventilation strategy to include cross-ventilation through peripheral and central zones and made the building longer, while incorporating the other strategies included in options 2 and 3. This has had the effect of reducing the cooling energy consumption even further. By conducting this analysis across a range of options, stakeholders can review the benefits and also determine the cost-effectiveness of the design. Modeling can also be used to assess the internal thermal conditions in order to verify that any chosen strategy does not compromise occupant comfort. Let's take another example, this time from a multi-family housing development in India. Occupant comfort is most simply evaluated in terms of the number of hours the internal temperatures stay below a particular maximum temperature, in this case 30 degrees Celsius. In the first option, which is the baseline, no particular effort has been made to limit the internal temperatures by design. As a result, only 30% of the hours in the year are under 30 degrees. For the remaining 70% of hours, internal temperatures are very hot. The inclusion of windows that are 100% operable, that is, that can be fully opened by the user, improves the baseline design but still leaves a significant amount of hours of thermal discomfort. External shutters, which can be closed during the hottest parts of the day to block out the solar radiation, have a very large impact in improving the internal temperatures. Partly opaque shutters have less of an impact. Assisted cross-ventilation is the strategy which has the most impact in this case. It is made up of windows that can open and a fan which increases the natural ventilation airflow through the space.